Hey, thanks, guys. Thanks for introduction. Appreciate the invite to come and talk to you guys today. Like he says, this has been a passion of mine because I do believe it's important, as you guys just saw from the people being interviewed on the slide before, or the video before. I was asked to come today to talk to you guys and I'm honored by the request, a little foundation for what AI is and what it's capable of, to kind of paint the picture before we get some real experts up here to talk through some of the more intricate implications of it. I'm going to make some gross oversimplifications and overgeneralizations for that reason, but hopefully it'll stoke a little bit of a fascination in you guys about artificial intelligence and specifically its application in Airpower, which I know you guys are interested in. So right off the bat, what do all these companies have in common? MySpace, Borders, Blockbuster, Excite. Yeah, bankruptcy, right? More than bankruptcy, they were all dominated, utterly devastated and bankrupt by adversaries with super, awesome artificial intelligence. The companies of Facebook, Amazon, Netflix, and Google were able to leverage superior AI to utterly dominate their area of the market. Why does my wife spend 3 hours a night looking at videos of cats and buying tens of dollars of things per month on Chinese merchandise? It's because they can tailor that specifically to her with that AI. They've dominated those markets. How do we do that in the DoD? How do we do that with Airpower? General Goldfein said that we must be able to create multiple dilemmas across multiple domains at an overwhelming speed while preventing our adversary from doing the same to us. This isn't going to be required in every fight, but it will be required if we do ever get to that fight with our near-peer adversaries. This is not possible without AI and augmented human decision-making. World War I was said to be won by brawn. World War II by logistics. World War III, if it ever comes to that, will be won by the ability to control the fight in time and by an information advantage. Vladimir Putin said last year, "He who owns this sphere will rule the world." And he was talking about artificial intelligence and cyberspace. So you're asking, how do I get me some of this AI? Well, hold on one second. I don't know if you guys are able to recognize the reference there, but AI is a tool, much like technology. It's not a destination. It's not an end state. It's a ways or a means to get you to where you want to be, and this is the ends up top. So this brief will very briefly talk about what is AI, some application areas, some challenges implicit in AI, and then I'll talk specifically about a weapon and target pairing example so that I can kind of bring that home for you guys with a specific example. This is my definition of AI. Others will differ, but I see AI as an unnatural agent, meaning that it's made by humans or other machines. It's not present naturally in nature, with an ability to learn and adapt from the environment on par or better than humans, meaning there's goalposts for what is intelligent. AI requires data so that it can learn from that environment. And AI is possible right now with the growing use because of exponential growth. Last year, there was more data produced than the previous 5,000 years of data combined. I have more power in this cell phone, a phone, than not just the rocket that brought the astronauts to the moon, but all of NASA at the time. That's power. AI is not a cookie-cutter approach to problem sets. Each individual problem needs to be solved by a tailored application of AI. And then lastly, if you have big data, you guys have probably heard the term big data a lot, the odds are that it's going to be able to tell you some correlations in the data, not necessarily causations, but from those correlations, you're going to be able to actually extrapolate those forward into understanding the environment and potentially the future as well. So here's a basic understanding of some of these terms you've probably heard before. Machine learning and AI are used interchangeably. They're not necessarily meaning the same thing, as well as some other terms that you guys have heard. Who here has kind of like a working knowledge of what AI is? Okay, cool. Who here's a data scientist, a software developer, engineer, or has programmed AI? Good, that's a lot. So sitting here 5 years ago, there would be maybe 1 or 2 hands, which means we're getting better at this. So after these briefs, go talk to those guys. Keep them in mind for the future. Think of these as like little Russian nesting dolls inside of each other with some little gaps for other forms of AI outside of their little Russian nesting dolls. Inside of AI is machine learning, meaning the machines are able to learn without being explicitly programmed how. Supervised learning is a subset of machine learning with labeled data. If you want to think about it, input X yields output Y. There's a direct tie there. You're able to train that using supervised learning, meaning there's a teacher for that, and actually develop that correlation through supervised learning. Implications of this you see on photographs of being able to identify dogs or people's faces, for instance. Obvious implications for the military there. Reinforcement learning. If you want to think about this as optimizing a score, anything that you can score would do well with reinforcement learning. For instance, video games. They've done extremely well at Atari games, for instance. Implications for that being code development and iteratively tweaking what you're going to be doing. I think you guys war games still in SOS. Iteratively tweaking little bits of that to minimize casualties, to minimize civilian losses, to maximize the destruction of the enemy, whatever you deem worthy of a score. Unsupervised learning is the opposite of supervised learning, where for input X, you don't necessarily have a direct tie to output Y. This is going to be good for any kind of clustering of where the data is or potential outlier detection. Obvious implications in cybersecurity for intrusion detection, for instance. And you guys have probably heard this, and this is almost synonymous with machine learning for you guys, but it's just a subset of that as well. It's been around for more than 30 years, but it's just now getting a lot of fame due to the ability to have massive amounts of data and train to that data to solve complex problems. In the neural networks, you basically have the inputs coming in on the left, feeding through a certain number of hidden neurons, loosely modeled off the human brain with synapses and actual dendrites, if you will, and then feeding out to a certain output. And then what you do with that output is going to determine how you apply it. So let's talk about some example areas. I basically see 3 different application areas broken up. Area number 1, we don't know the rules governing data. Either there's so much of it, or we aren't able to see as a human the correlations in that data. That's a good application area potentially for AI. It's able to actually understand the correlations without us understanding the correlations. An example of that use would be mapping adversarial networks. Area number 2, where we know that correlations exist, we can very loosely describe them, but we can't actually program them for a computer. You know what a 3 or an H looks like as a handwritten letter? It would be very difficult for you to program that using white or black pixels on an envelope, for instance. Implications of that in the military, just like we talked about image recognition of a SCUD site or an SA2, or in full motion video, identifying a middle adult male or a building or something of significance for you. And the third area would be any area where we could code an explanation, but it's either so large a scale or it changes so rapidly that it's impractical for humans to develop that solution iteratively. For instance, an ATO process inside the Joint Air Tasking Cycle in our CAOC or AOC. Right now it's a 72-hour process and done in 24-hour chunks of the ATO. What if we had the ability to do that planning daily and then have a 10-minute or 5-minute ATO production iteration? That would provide great potential use. Here's some of the challenges, and this is just a couple of them. I'm sure some of the other speakers will talk extensively about this. AI is very good at very narrow application areas right now. It's not very good yet at broad or general applications. So it might be able to solve that very narrow problem of playing a game Go, which has rules. It could be more difficult in applications of strategic warfare. Artificial general intelligence is said to be the holy grail of AI. Once you get the ability to cross domains with taking one knowledge in one area and then applying it to the other, that's said to be very, very powerful. And that's what some of the people earlier were talking about as the greatest existential risk to humanity. It could also be the greatest help to humanity. Overpromising and under-delivering for AI is extremely dangerous. We've seen examples of this with the potential for Watson to cure cancer and then not delivering on that, but still was able to do some very narrow areas such as breast cancer. You run the risk of either jading people or having safety and security negative implications if those fail short. How we tackle that is through adaptive or agile development. We don't try to eat the elephant as one bite. We take little bites of that elephant, and then over time, we notice that we've actually made a lot of progress in eating that elephant. We need experts, and you guys might have been told this already, but you guys are those experts. You guys are the people that are going to go out there and make those bold transformations of the force. If you guys have been told to be those bold decision makers and you don't know what that means, ask later in the questions and answer session. I'll be glad to tell you. But you guys are the ones that are going to be able to fix this. And lastly, safety and security start from day zero. The trust needs to be built in from day zero, not built in after the fact. We'll look specifically at the tactical to operational level. I don't think it's very easy to tackle the strategic level yet, but we'll get there eventually, but that's inherently human in its nature. The tactical level, I think Paul talked pretty extensively on the autonomy, out at the tactical edge, having those computers decide and act autonomously. AI assistant could be applicable throughout the spectrum. If you want to think about Alexa next to a decision maker or operator, hey Alexa, what's the collateral damage on this weapon? Hey Alexa, what is the assessment from yesterday? Tell me my measures of effectiveness were, etc. Great potential there. In augmenting human decision makers so that they can actually make the decisions that are important and that those of those ranks are the only ones that can make. Tailoring a common operating picture is absolutely huge. If you have a data cloud or lake, you need the ability to pull out the specific information or data that you need, tailored differently to that kernel than that captain in that jet. And then we talked a little bit about the joint air tasking cycle in developing that ATO. In that, we need to make weapon and target pairing decisions. For target X, this is the best weapon that I have available to service that target. And that's a specific example that we'll look at now. So looking at the weapon target pairing, we talked a little bit about a neural network. This is a representative of what this could look like. So coming from the left in the inputs, you have target characteristics and environmental characteristics. Those are inputs to the system. Those are going to be fed through, be it target type, number, mobility, hardening, GPS availability, any obscurations. Fed through, and then the output of that system could be a PK or PD, whatever your desired output would be, for you to make decisions on. You can't just take the output of this neural net, for instance, and go with it, because this 1.0 in this case would correspond to a nuclear weapon, and you're not going to use a nuclear weapon even if an individual is out in the open, because we have rules. So this 1.0 is cut off, and you have those rules applied, being ROE, be it LOAC, and other methods to achieve your desired prioritized list of weapons. And that potentially could be automatically paired to targets, or having assets re-rolled real time with that iterative ATO cycle that we talked about. In order to assess if something is successful, we need something to compare it to. Is that neural net better than a human at pairing targets? If it is, let's try to come up with another example of use and then see if that's better than the neural network. This is one of the most simple forms of AI that we have right now as far as efficient running of that. And it's called the nearest neighbor, and it's just like it sounds. If we have in this LA gang scenario a map of Los Angeles and knowledge of where we pulled an individual off the street, we can guess his gang affiliation by looking at his nearest neighbor. Since he lives on the 18th Street, it's likely that his gang affiliation is going to be the 18th Street gang, because that's the next closest example. Extrapolate that forward in a high-dimensional space with those same inputs coming in on the left, matched with the best weapon pairing, you're able to come up with the example that closest resembles your test example. In this case, plotted in high-dimensional space, if you want to think 10 dimensions, so not exactly depicted here. The test case lies here. The closest example using a Euclidean distance is this example, which is the GBU12 contact fusing. So same exact output, potentially, run very different with different algorithms and models. So we talked a little bit about what AI is. It's an unnatural agent with the ability to learn from the environment on par or better with humans, meaning that we can actually use it. AI is a tool. It's not an end or a destination. There are countless areas ripe for disruption inside and outside the military. Hopefully, AI will provide the next US overmatch versus our adversaries in the agility that we need to combat near peers. AI success or failure, lastly, depends on our implementation of it. And hopefully we can have you guys be those bold implementers that we were talking about. Appreciate your time. Thanks.